So, as we were saying, it's really easy to make simple mistakes and turn those into some big problems when you're working with Azure or any cloud solution. And so I'm going to walk through a little bit of what do we see in the consulting world and how can you avoid making the same mistakes? I'm Ken Muse. I'm the VP of Professional Services at Winelect, an Atmosera company. If you have heard of us, it's probably because of the awards or the books we've written. And if you haven't, we're a consulting firm that specializes in helping customers onboard to Azure and take advantage of it. And in doing so, we see all kinds of mistakes. We get to see the things that people do and the things that they wish they had done right the first time. These mistakes generally fall into four broad categories. The obvious ones, the ones that, okay, you should have known better. The ones that happen when we assume failure isn't going to occur. If we're coming from the world of being enterprise developers working on-prem, it was always someone else's responsibility to keep the lights on and make sure the machines were running. And so that sometimes led to bad habits. Knowing our limitations. What can the services really do? And what are we just reading the marketing on? And then monitoring. If you're not looking ahead, if you're not watching for the problems, they're going to sneak up on you. Some of these mistakes are simple development issues. Some are about knowing the platform. All of them surprisingly common. And they really begin with, what are those obvious mistakes? Now, this is actually a picture from a real customer site. They actually did have the smoking area right next to the diesel fuel. Some mistakes, very easy to recognize. And the first of those is not upgrading your development tools. If you're still working with Visual Studio 2015 or 2017, if you're using legacy products because, well, you haven't been able to upgrade yet, you're on older OSs, then you're missing out on all of the performance improvements and security patches that make the job easier. Bug fixes, improved tooling, functionality fixes. Everything really starts with the developer and the tools you're using, because if you've got a very dull saw, it's going to take a really long time to cut down that tree. And in Azure, if you're working with old tools, it means you may not get the same visibility, the same functionality, or even the same behaviors that come with having modern tool sets. On the other side of that, on Azure itself, if you're not keeping up with the platform changes, then you're probably doing it wrong. If you're assuming the technologies don't change or the patterns you use don't change, you're going to run into issues because Azure changes frequently. Azure changes daily, in some cases hourly. If you've ever wondered why the exams require you to recertify, to re-up so frequently, why they expire so quickly now when they used to be good for 2 years, it's because you've got more than 100 teams creating different products on Azure, and each one is updating at such a rapid pace to keep up with the industry. If you're not keeping up with the parts of the platform you use, you're behind the curve and you're going to start missing things. Worse, you're going to start getting the least value out of some of those products. You're not going to understand new functionality, new ways to do things. You're not going to get the advantages that come from having the newer, better code available to you. And in more extreme cases, like for example with Azure Data Lake Storage, if you find a tool you like, Microsoft updates it, and you stick to the old version, eventually it's going to be deprecated. And you don't want your site going down over something avoidable like simply upgrading and using the correct version of a product. So keep up with what's changing on Azure. Subscribe to the RSS feed. Make sure you understand what's new and what's changing. If you don't have time to keep up with everything, pay attention to the couple of conferences Microsoft has each year and the book of news that comes out of each conference, providing a summary of what do they think you need to be aware of. Now, along the same vein, we tend to see failures coming from a specific niche in this, and that's not patching virtual machines. We got away with this for a long time in the on-premises world, but if we're in Azure, we don't have that same flexibility. We can't just let it ride and hope for the best. The truth is, on premises, it was a bad idea to begin with because it meant security exploits were making their way to us very rapidly. A few years ago, there was a common blue screen of death issue where VMs suddenly stopped working, and when you rebooted, nothing happened. The reason behind it? Azure expects the VMs to start up fairly promptly. It gives them a short time in which they either start up or shut down, and if they don't do it on their own, the Azure Fabric takes over, repairs it, and moves on. A number of customers weren't taking their patches in a timely manner, getting 90 days or more behind. Windows forced an update. And if you've ever taken an update, you've seen that warning, do not restart while the update's in progress. Well, after the timeout, Azure decided the machine was out of control, restarted it in the middle of the update. Next thing you know, that virtual machine completely unusable until you log in through the console and do a bit of manual repair. All of it easily avoided because if you're taking your patches regularly, Azure fully supports that, and your VM's getting updated. To help you do that, Microsoft even put an extension on each VM, enabling it to be able to take patches and for Azure to be able to monitor them. So this part of the process is really simple to keep up, but if you don't do it, you're asking for downtime. Now, when we speak about VMs, there's another area that we commonly see people make an obvious mistake. They assume it's a VM. Everything's the same. I'll talk about this more in a moment, but if we assume that Azure is like every other VM, if we treat it like AWS, VMware, GCP, then we're not getting the best out of what Azure has to offer, and we may be paying substantially more for what we're trying to do on Azure. So in this case, it may not result in a failure, but it may result in extra expenses, lost performance, not getting the most out of your environment. Similarly, we love to talk about Docker as being this universal approach, containers, Kubernetes, a way that we can be cloud agnostic. And for the most part, this is true. But even within a container world, there are optimizations you can do for each cloud, Azure in particular, that optimize the containers for their environment. They enable you to use native Azure resources like blob storage and files, as opposed to sharing disks. When you take advantage of these features, you get the most out of the environment. And if you misconfigure any of them, again, you're failing to take advantage of what the platform provides you. If you're trying to use everything as a VM, you're also missing out on the platform services. Things like blobs, files, PaaS offerings, Cosmos DB. On containers, if you're thinking everything is Kubernetes, well, you've got app containers, container instances, functions, ways of doing lightweight orchestration on individual containers without needing an entire Kubernetes cluster. And if you need a cluster, are you looking at AKS, Azure Kubernetes Service, so that the cluster is managed for you, minimizing how much you've got to maintain VMs? Again, if you assume everything is just a VM and treat it like that, you lose a lot of the benefits of Azure, and you're going to pay more. Moving further in that stream of thought, as we move on to the PaaS services, we love to say, it's just like IaaS. I'm using app services, it's like using IIS, or it's like Nginx and Linux. We assume everything's identical, that the best practices are identical. Performance is identical. In truth, the PaaS services are highly optimized for specific use cases. And if you're using those services the way they're meant to be used, then you're going to get the most out of the platform in terms of reliability, performance, and resiliency. As a practical example, an IIS instance running on a VM supports the Graphic Display Interface, or GDI. It's what some applications use for rendering images, PDFs, creating video content. GDI can be very fast, but Microsoft has long documented it's not server safe. When we move to app services, GDI is not available. If your app relies on it, if it's been violating that best practice, it won't run correctly inside of the app service plan. So little differences like that, where the plan is either optimized for a use case or where it forces you back to best practices, often catch developers off guard. So it's important to understand these. Another great example in this vein is if you're using Azure SQL. SQL Server on premises, you have a lot of control over the behavior of the disks, the allocation of the performance for the log, the latency, the speeds, how you scale up and how you scale out in terms of individual instances. In the cloud, some of this is configuration settings. Some of it, such as the maximum log write speed, are hard limits. That means your application has to be aware of those things in order to really take advantage of them. That also means there can be performance differences when we move from an IaaS service and a server in that environment to a PaaS service, which has built-in redundancy and an ability to scale on demand. There are trade-offs in every system, and PaaS systems make some trade-offs you need to be aware of. And so if we assume everything is always the same, whether it's VMs are like VMs or PaaS is like IaaS, that's an obvious mistake that will cause us challenges as we try to adopt Azure. So with all of these challenges that are so obvious, the next one may seem a bit less obvious, but it's a common pain point, and that is not purchasing a support plan. If you are using Azure for production purposes, you need a support plan. The reason for this is if you don't have that plan, you're not planning for downtime. You're not planning for inevitable issues, whether your own or something happening with the service that's unexpected or may represent a partial outage. Accidents, issues, problems you might have, accidentally deleting something you need to recover. All of these require an active support plan for resolution. Without a support plan, you're not going to be able to get a hold of anyone in order to solve the problem. And the type of plan your company purchases directly impacts how responsive Microsoft support will be. Remember that SLAs start with how long does it take to respond, and then move to how long does it take to fix the problem. And there are different tiers of this. When we start at the lowest level plan, the developer plan, we get an SLA for that initial response of 8 hours for a critical issue. So as a developer, that may be perfectly reasonable. For production, Can you really afford to wait 8 hours when your production system is not behaving the way you expect? A standard support tier changes that. You get 24/7 access, and critical issues get a response within 1 hour. So in that case, you're now looking at, in a critical situation, within 1 hour, someone is working with you to get it resolved. And for non-critical issues, within 8. For bigger companies, for more critical loads, there are even higher plans that bring that response time down to 15 minutes or less and provide someone that will actually walk through the problem with you. But if you don't have any support plan, then when a problem arrives, you will be unable to find a way to deal with it, and you'll be struggling to quickly try and onboard yourselves into a support plan in order to try and get that assistance. This is a very common mistake. It's a common oversight, and it's definitely one we encourage companies to really consider long and hard before they go without. So the next class of issues we tend to see really are the ones that come from assuming failure won't happen. The truth is, if we're in the cloud, in fact, if we're doing development, failure is probably one of your only guarantees in life. Sooner or later, everything will fail. The region you're in Azure will go down. The code you wrote will encounter a bug. The network will have high latency and suddenly something won't respond. Sooner or later, everything fails. A few years ago, a major outage across the entire East Coast was caused by low-level hardware issues. Routers all over the eastern United States ran out of memory to store all of the IP addresses that were now available and online. Consequently, the eastern half of the US lost access to anything on the internet for a period of time. In another situation, a major outage happened when a utility line was being repaired, and they dug up all of the internet fiber lines going into a major city. And when I say all, I mean the redundant lines as well. They managed to get everything because they all entered at the same point, and that is the exact spot they happened to dig that day. Failure can and will happen. And if your code isn't considering that, then we're making a mistake that will eventually catch up with us. All code should implement some sort of retry logic. This is one reason that Netflix implemented a concept called the chaos monkey in their systems that randomly shut down services. This kind of an approach ensured that all of their developers were always planning for failure, because if their service failed because another service failed, they had developed their code wrong. Just because one service fails doesn't mean you can't write code to make yourself more resilient to issues. So, can we make something read-only? Can we gracefully let users know there's a problem? There are multiple ways of handling this, but doing nothing is not an option. When we implement retry logic, we should also consider circuit breakers. Circuit breakers are a concept that says basically, when we have enough failures occurring, turn the whole thing off. Stop trying. This issue was the root cause of a Skype failure several years back. A simple system outage and the login servers went offline. They had a handful of login servers and peer-to-peer networks that really helped to offload a lot of the login capabilities. The problem was when the login servers failed and then came back online, first one system asked, then the next, then tens of thousands of systems, and then hundreds of thousands worldwide all came in at the same time because they were stuck in retry loops. The servers were overwhelmed, crashed, went offline, and when they came back, hundreds of thousands and then millions of requests were waiting. A circuit breaker would simply say the service isn't available. I'm going to stop and occasionally retry until it comes back. Once it comes back, then I'm going to stop throttling and let everything through. An extension of this entire problem, and one that the example I gave with Netflix seeks to solve, is planning and failing for the systems to fail and your failover practice. And an adjunct to that, how you're auto-scaling. Because if you're not actually testing it, if you're not actually trying it, then you're assuming the failure won't happen and that everything will succeed in the failover or the auto-scale. In truth, many times our first attempts to set this up make simple mistakes, and those simple mistakes lead to the failover or the scale not working as expected. For example, if you're using .NET full framework all the way up through version 4.8, and you're using web forms as part of your solution, you may be relying on ARR, part of app services, to ensure that you can keep using sessions and cookies by going back to a single server. Well, in that case, you're pinned to a server, so as loads increase, you won't be able to move to another server in the cluster. The problem is there's an amount of time taken before a cluster will increase in size, and the incoming requests are assigned to a server until that happens. You can see the problem. If I get a sudden burst of activity, 2,000 people trying to visit my site at once, all 2,000 will go to the existing, already overwhelmed app services. The new instances will spin up and will sit there idle, waiting for the next set of people to come in, while the rest of the system's overloaded. This is what I mean by testing even your auto scale. Because in cases like that, there are simple solutions, but if you're not testing it, then you're missing it. And I'll add one thing here that's common when we're doing all of this. If you're using Azure for production, make sure you're using resource locks. You don't want to be deploying resources into that environment and assuming no one's going to delete them. A resource lock means that even an administrator has to pause and think before deleting a resource. It prevents accidents that can cause one of those failures. So from a development perspective, there's a lot we have to keep in mind if we want to avoid failure and be able to be resilient to it. Part of that is making sure that we take advantage of redundancy in Azure. Redundancy is often misunderstood. When we say something is triple redundant, it means there's 3 copies. It means that we're also saying that we're minimizing the chance of any sort of corruption of a file or an inability to get to that item when we need it. Minimizing does not mean eliminating, but it also doesn't mean that you can't make a mistake yourself. If I use Azure Blob Storage, I've got 3 copies. If I make it geo-redundant, I've got 6 copies of my data. If I delete that blob file, I have 0 copies. Now, if you have a support plan, they can sometimes bring things back. And if you've enabled soft delete, which is recommended, you can bring it back. But redundancy does not prevent mistakes where you choose to do something or where you programmatically eliminate something. Redundancy also has some rules to it. If you really want to take advantage of redundancy and resiliency, you need to understand how these rules work. How does the failover process affect you? And to be clear, redundancy is having the duplicates of our data, while resiliency is, can we recover from the fault? Something went wrong, can we get back running? These two are usually tightly coupled, and Azure regional pairs are part of that. When we choose to create something that is geo-redundant, Azure will choose a region specifically for that geo-redundancy. What happens in this case is it's going to use its regional pair, a second region that's tied to the region you're in that is specifically responsible and optimized for this. Now, that means better performance, but it also means something else. If our code is being deployed, if our systems are deployed with regional pairs, Microsoft guarantees that in a worst-case disaster scenario where the entire global network is impacted, Microsoft will prioritize one member of every regional pair for recovery. That means that if I'm failing over and I'm using that geo-redundancy, I'm going into a regional pair, then I'm guaranteed that in a worst-case scenario, one of the two sites I'm in will have a priority for recovery. I see a lot of customers pick things purely on region. I'm in East US 2 and West US because I got people on both coasts. I'm in Northern Europe and in Singapore. Well, it's wonderful to have the systems in multiple parts of the world or multiple parts of the country to be able to support your particular users and give them lower latency. But if my resiliency and redundancy strategies are tied to that, I may have happened to pick the two members of two different regional pairs that are each not the member prioritized for recovery, meaning that in the event of a global outage, I'm going to be sitting on my hands watching everybody else come back online while my application's unavailable. So if you're trying to create a redundancy and resiliency strategy, you're trying to test and build failover, always consider the regional pair for your resources. Your Azure region choices are important. Now, kind of going into the same vein, if we're assuming that things won't change under the covers, that things won't fail on the Azure side, it's a bad assumption. Systems are rebooted, rebuilt, fixed, and replaced all the time. They get brought in by the shipping container load, installed, and pulled out in large groups of racks all at once. So if you're relying on things not to change, for your system to always be there, then you're making another common mistake. This goes back also to the example I gave with if you're using application request routing, ARR with app services. We're assuming we always go to the same server. But what if that one's scheduled for maintenance at the time the load hits? What if the server itself fails under that load or has an issue? What if someone accidentally unplugs that particular box in the data center? If our code is tied to going back to that single unique instance, it won't fail over to the system that replaced it. This also happens with VMs, though in a different way. VMs tend to appear to pause and then come right back as maintenance patches are applied or as the code and responsibilities are shifted to other hardware so that they can replace the hardware underneath the current instance. Those brief hiccups, even if they're only a few seconds, can still cause issues, especially if you haven't done things like retry logic. This is why we also encourage you to think of resources as disposable. The more you rely on named servers, on always being able to upgrade that single instance, it's just a VM, so I'm going to care for it, maintain it, feed it, just like a pet. Well, I'm starting to depend too much on that one system and that it doesn't change, knowing that change is in fact inevitable. By comparison, if I replace that server hourly, daily, weekly, it means that I know exactly how it's configured. I can automate that configuration, and I can guarantee that if I had to rebuild the entire environment, I'm always one step removed from having a brand new environment that I can trust. And that also helps us for larger scale deployments, because instead of a rollback model that is, I'm going to put old code back and hope it behaves the same, I could just simply deploy a parallel instance on brand new hardware, taking the latest and greatest updates to the operating system, no patching necessary, route traffic to the new environment. I could deploy to a new app instance. By everything being repeatable, then I don't have to worry about what if I lose that box. So I've mentioned a bit about resiliency and redundancy. And this is where other companies tend to go wrong, is they think that being in the cloud sometimes means we're available. It's running in the cloud, so it just works. It'll just fail over. They hope it all comes together without any testing, and if they need high availability, it's something they can add on at a later date. But you've got to actually design for high availability, test for it, prove it works, and then prove you can fail back. If you aren't doing that, then when the time comes, you won't actually fail over successfully. And if you're hoping the cloud will just work, it absolutely will. But if you're relying on Microsoft to choose when to declare an outage, their choice may not align with yours. For example, if they're waiting for 10% of customers to have an issue and you're in that first 0.5%, are you really wanting to wait for your system to be declared to be in failure? Are you able to take that kind of downtime? If not, then you need to plan for your own availability. Not just what do I do when a region fails or a system fails, but also how do I fail over myself if I believe there's a problem? If we think the cloud is available just because it's the cloud, then we're missing out. And then in the same vein as all of this is our bad production environment. This one's the easiest to avoid because we can just simply automate our way to success. If we're doing production by hand, we're inviting failure. We're making processes that aren't truly fully repeatable, and we're having to give higher levels of access to people in order to do production work. If we're automating, then we can fix that. We can lock down the environment. We can make sure that everything is repeatable. And as I mentioned before, part of that deployment, using a resource lock as part of your strategy. We don't want someone to accidentally change an environment without having to stop and think. And then probably one of the single most common things we see, trying to put development, possibly QA even, in the same subscription as production. This is inviting trouble, not just because of resource limit constraints in Azure. There are certain counts of resources you can go up to, but also because of a blast radius problem. As I start automating, if something goes wrong and what I'm doing in development spreads, I could impact my production stability. And on another note, if you aren't taking advantage of dev test subscriptions and you have that opportunity, well, you could also be substantially overpaying for the same Azure services. A dev test subscription is simply a subscription where you have no SLA on the resources, and because of that, you have a much lower cost on a lot of your compute resources. This makes dev test less expensive, and at the same time, it gives you a way to separate out production from the dev test world. Now, these kind of mistakes often go hand in hand with not quite getting how SLAs work in Azure. If I've got an app service plan with a 99.95% SLA, that means I could have up to 21 minutes of downtime per month at any point in time without Microsoft having gone outside of their guarantees. When we pair that with something like Azure SQL with 4 nines, 4 minutes of downtime, we often assume this means our SLA is either the best of these numbers, 99.99, or more commonly, that it's the worst of the two. That we're looking at 21 minutes or so a month of possible downtime. In truth, SLA is actually the combination of all the resources and any sort of regional failover strategy you've created. That means the downtime, whenever the resources are in the same region and require each other, is additive. So instead of 21 minutes, we're now looking at closer to 26 minutes of downtime in 1 month, potentially. Now, when we create those resiliency plans I mentioned, then what we're saying is, as long as one region or the other is running, I'm still okay. Well, in that case, the numbers actually will go down because in order for failure to occur, I need a region to then go down. So as long as one region is available, I have an improvement there. And so it reduces the overall chance of something failing by having the multiple regions, by having the resiliency, by using availability zones even within the single region to allow failover between individual data centers in a region. SLA is a combination of these parts, and I encourage you to spend time reading and understanding it. And that reading takes us to the next area, the things that are limitations, things we may need to know to be successful. And the first part of that comes from the SDK, the developer side. Are we using it correctly? Read the docs and make sure you understand them. I frequently see users of the SDK creating new instances of each of the client classes, whether it's for a document DB or one of the other Azure services. They tend to frequently do this by creating new instances per request. And yet the documentation is very clear. They should always be singletons. They'll handle the connections for you. They have safety across the requests, but the client must be a singleton for the life of the app. Under the covers, this relates to how HTTP client is used and whether it gets disposed, which .NET full framework frequently left you in a position of disposing it. And it's one of the few iDisposable resources in the .NET framework where that is a really bad idea because it causes you to close an HTTPS connection. A closed connection is expensive to recreate, and it has a 2.5 to 4 minute waiting period before it can be recreated. Sooner or later, you will run out of available sockets and you'll start having connection issues. Using a singleton client will help to alleviate this because it will manage and pool the connections for you. If you haven't adopted .NET Core, this is another advantage in that framework. The HTTP Client Factory was implemented, which also manages the pool for you. And so when you request a client through dependency injection, you're getting an instance that's actually a pooled instance whose lifetime is being correctly managed. If you're not doing this, if you're disposing of your client, if you're not using singletons, then you will eventually run out of connection. You will hit an outbound connection limit. Azure uses a feature to be able to map your ports to the outside world to allow a response to come back when you make a request out. This is true in functions, app services, VMs. The lower level you go, the more connections you have available. For example, you may be able to get as high as 1,000, 1,200. Whereas as we go to the higher level services, you may get down to as few as 128 available snap ports. And each of these ports can handle multiple requests, but only if you don't close it and dispose of it. So make sure you understand the SDK and its limits in every platform you use. Similarly, queues. If you're forgetting that a queue has at least once delivery guarantees, you're going to have problems. Most queues by their nature guarantee that you'll get a message at least once. Any other guarantee beyond that is unfortunately harder to come by. And we also tend to assume order is always guaranteed. But what happens if a system processing a queued request suddenly crashes, fails, doesn't respond in time, and the message is requeued? Well, now the things that came after that message may already be processing, and our message may get played again because the queue was not aware that it got processed or that that process was successful. So with any queue, we need to assume we may see the same message again and have to deal with it. And that's the basis of a common issue in Azure Functions. We may process the same message multiple times because it is a queued environment. It has an at least once, not an exactly once guarantee. And so if we're not taking advantage of the full design of the system and being mindful of that, we may encounter some issues. Similarly, we need it to be stateless, idempotent. I should be able to run it again, because if that message comes in again, I should still have the same outcome, the same response. If I'm doing that, then I can receive the same message a million times, and I'll have the same one outcome. The nature of all of this is part of why Azure Functions is not designed for long-running functions. It's designed for short functions or the orchestration of lots of short functions together. Because the longer we run, the better the chance that all of those issues we talked about before, including system failures, occur, and our message has to be requeued and start all over again. A message that only executes for 1 second is far less likely to have a catastrophic failure than a process that's running for 15 minutes. And the consequences of recovering are a lot shorter if I can pick up where I left off than if I have to rerun an entire 15-minute process. One of the other obvious documentation errors is picking the wrong kind of SQL platform. Picking Synapse because you think you're using big data. Are you over a terabyte yet? If not, it's not the right platform. And if you need high concurrency, well, Synapse is designed for something else. It's not a high concurrency. You may be looking at Azure SQL Hyperscale. Similarly, if you need to have lots of computers slicing and dicing the data, then you may need Synapse. It's really about picking the right platform to meet your specific needs. And that more broadly goes to all of the database solutions. Whether it's Azure SQL, Databricks, or Cosmos, every data solution is optimized for very specific use cases and has specific requirements to meet those. If we're just picking something because it's what we've used or we've heard is good or we've heard it's fast, we may be using the wrong solution and getting the worst performance. For example, Cosmos DB performs really well, but it is not designed for sets, aggregations, things that require group by or returning large numbers of data results. It's optimized for point queries, find by ID. If we pick the wrong solution for our job, we're going to get the worst out of it, and it may not even work right. And going even beyond the database, that goes to the storage level. Each of the different storage offerings, from blob storage through Azure Data Lake Storage Gen 2, are optimized for certain use cases and should be used to support that use case. If we're using things in a way they're not intended, we'll get the worst out of it. And so we want to make sure we're always reading the docs and understanding what was it designed to support. A lot of people don't realize blob storage out of the box doesn't truly have directories. It has one big directory with lots of files that you're iterating through each one and then looking at a prefix. Data Lake Gen 2 actually does have a directory concept, but for those guarantees, it comes with other limitations, things it can't do. And picking things based on understanding the limits also applies to things like VMs, where our ability to meet the full capability of a given disk size really is restricted by what can that VM do? How much network does it have access to? How many cores can it really use? And are those cores physical or virtual? If it's a virtual core, it may be half core, that is hyperthread and then physical core, as opposed to a physical core with a hyperthread. Understand what the limits are with the VM you're using, or you're making that same mistake. And this doesn't just go with the size of the VM. The SKU is a similar consideration because the VM SKU is optimized for a specific purpose and will therefore have strengths and limits. The L series fine print in it, optimized for local disks. Well, what that means is it's not using network disks. It's not triple redundant. You have to have a redundancy strategy. If I'm using the B series, it supports burst mode. If I'm using it at full capacity all the time, it's throttling. I'm actually not getting the full power out of the system, and I'm losing a lot in the process. So understand what each SKU is and what it provides. And then going even further, understand that within these, you have latency limits and resource limits. Only Cosmos DB has an SLA on latency. Everything else has targets. And if we're talking about HDD drives on virtual machines, those targets are best case scenarios and not guaranteed. You do not have allocated bandwidth. You have up to bandwidth. Newer technologies, the SDDs, the P series for production workloads, give latency guarantees. That's especially important if you use Azure Front Door, which expects a response within 30 seconds. An S-Series app service plan has no latency guarantee and may respond in some cases after a minute or two. Doesn't happen often, but it only needs to happen a couple of times before Front Door will declare the site down and refuse to route traffic to it until it starts responding consistently. P-Series has better guarantees on latency, and that's why they're recommended for production. These kind of limitations, whether it's the latency, the maximum concurrency counts with databases, the response times, make sure you actually read and understand the limitations of any resource you use. Otherwise, you may not have what you think you have. Most customers are surprised to learn that Synapse stops at 128 concurrent connections, or 128 concurrent queries, not connections. Whereas Azure SQL can go substantially higher. Many customers are also surprised to learn that while HTTPS triggers can scale for functions once per second, queues and other types only make that call every 30 seconds. Again, know the limits, because what you don't know will eventually hurt you. And then the last two items are really simple ones. Make sure you're using the built-in Azure security. If you're trying to home grow it, rely on Active Directory, build up your own, instead of using managed identities. Then unfortunately, you will eventually encounter some challenges in your environment, and you're not fully protected. Azure Security Center will guide you but only if you follow the guidance. And if you're going for compliance, there's usually an accompanying document in the Azure Doc site that will guide you through what are your responsibilities outside of Azure to achieve that compliance, because they cannot guarantee full compliance any other way. And if you're developing and deploying applications, make sure you're using Azure Monitor. App Insights, Log Analytics. These are tools that allow you to proactively identify issues, performance bottlenecks, downtime, server-side issues, resource utilization constraints, and recover from them before your customer knows. If you're relying on something else, that something else is either not getting the full picture or using Azure Monitor under the covers, which means you're going to want to make sure that it's seeing the right things. Properly using Azure Monitor can be the difference between understanding where your issues are coming from and getting ahead of them, and having a system that's completely unavailable and you don't know it. It's natively integrated in across the entire Azure platform, so it's already trying to gather these metrics for Microsoft to know the stability of the systems, whether or not you're using it. So take advantage of it and the fact that it will perform well. Because at the end of the day, planning is everything. And if we're thinking through these, we're looking at it, we're documenting it, we're reviewing it, then we're less likely to see these common mistakes that everyone else is making in Azure and have a successful, stable, and resilient deployment into production. And for those of us that are developers, stable production means nights and weekends that we can use for other more enjoyable things, such as writing our next favorite application. And so with that, I thank you all for attending, and I'll turn it over for any questions.
Yeah, we're here.
And I'll add one last thing here. After this, you have any questions, please feel free to reach out directly through Twitter or LinkedIn.
Yeah, absolutely. We'll do that. We'll do so. We do have one final question. I mean, we would have more, but no so much time left. So one question and then.
Well, I was wondering, because you've touched a lot as a result of these mistakes, a lot of impact on some quality attributes when it comes to architecture. And I have this question in my mind: if there is any way in which we can, I don't know, any tool out of the box, maybe in Azure or something in discussion, or I don't know, for the future, that allows us to actually control some architectural metrics, let's say. As in, for example, for the structure, at some point I used a library ArcNet for .NET. There is also a version for Java. And I was wondering if we have something like this for other I don't know, quality attributes that help us to actually control that, and not, you know, do a lot of maybe separate testing and keeping in mind a lot of things, you know, just making things easier.
Yes, we actually have 3 things that are available. The first is, if you're using .NET code, the Roslyn analyzers can look at your code to identify a lot of common mistakes. And there are analyzers that people have created to look for some of these common issues. If we're doing infrastructure as code, we have another opportunity. The new Bicep format that Microsoft has analyzers integrated in to also try to look for common mistakes for you, so you can catch things while you're coding. Okay. And then if we're using Azure's monitoring services, the Azure Advisor can actually look across all of our deployments, especially those dev ones, and advise us of best practices we may have missed. And so, yes, there are tools that can help us, native and built into our platforms.
Okay. And they are custom. We can custom do some rules custom in order to satisfy, I don't know, certain types of requirements? Just
Yes, so the Roslyn analyzers can be fully customized, and Bicep has plans to enable customization of those rules in the future around the time they hopefully get to the 1.0 release. The Azure Advisor, not as much so, but through Azure Monitor, you can create rules and alerts that allow you to implement those custom analyses yourself.
Okay. Thank you very much.